Nothing can be taken for granted when you get to Mars. There's a lot of things we just don't know.
Space always has a way of throwing us curveballs and surprising us.
I mean, until we get the data that says we're on the ground safely, I'm going to be worried that we're not going to make it.
Entry, descent, and landing is often referred to as the 7 minutes of terror because it takes about 7 minutes to get from the top of the atmosphere of Mars to the ground safely.
The spacecraft has to do all of this by itself.
There are many things that have to go right to get Perseverance onto the ground safely.
There's a lot counting on this. This is the first leg of our sample return relay race. There's a lot of work on the line.
Starting about 10 minutes before atmospheric entry, we get rid of really the spacecraft part of the rover that's been supporting us.
We come screaming in to the Martian atmosphere at 12 to 13,000 miles per hour.
And the heat shield is what dissipates all that initial energy through friction.
The vehicle will continue actually flying itself through the atmosphere. It's sort of like a transforming vehicle that went from spacecraft and now it's kind of like an aircraft actively guiding itself.
When we're going slow enough, we deploy a parachute.
It's the biggest supersonic parachute we've ever sent to another planet. It's critical for slowing down the vehicle.
Perseverance's entry, descent, and landing borrows heavily from that of Curiosity.
But fundamentally, Perseverance is a different rover. She's bigger, she has different instruments.
We've added a lot of smarts on the inside to make it more capable so that it can deal with the landing site that we've given.
The science team identified Jezero Crater as basically an ancient lake bed and one of the most promising places to look for evidence of ancient microbial life and to collect samples for future return to Earth. The problem is it's a much more hazardous place to land.
You look at Jezero, all you see is danger. How do we go to a site that we never thought was safe enough to go to before? So the heat shield, which has protected us all the way through entry, is no longer necessary. We need to get that off so that we can actually see the ground. And we can see the ground in a couple different ways.
Perseverance will be the first mission to use terrain relative navigation. So while it's descending on the parachute, it will actually be taking images of the surface of Mars and determining where to go based on what it sees. This is finally like landing with your eyes open. Having this new technology really allows Perseverance to land in much more challenging terrain than Curiosity or any previous Mars mission could. Amongst the rocks and the craters and the cliffs, these things are hazardous to the rover, but these are the things that are interesting to the scientists.
Once Perseverance has figured out where she is, we jettison the back shell and parachute and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the sky crane maneuver. And once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. Surviving that 7 minutes is really just the beginning for Perseverance. Its job, right, being the first leg of sample return, to go look for those signs of past life on Mars. All that can't start until we get Perseverance safely to the ground. And then that's when the real mission begins.
The images in this video are all real, captured by NASA's Mars rovers, directly from the surface of the planet. This is the first time Martian footage has been rendered in stunning 4K resolution. So sit back, relax, and enjoy this journey across the surface of another world. The team at NASA has given Mars informal place names, which you will see on the screen in the bottom left corner. The footage was mainly captured by the three most successful rovers, Spirit, Opportunity, and Curiosity. The cameras on board the rovers were the height of technology when the respective missions were launched. A question often asked is, why don't we actually have live video from Mars? Although the cameras are high quality, the rate at which the rovers can send data back to Earth is the biggest challenge. Curiosity can only send data directly back to Earth at 32 kilobits per second. Instead, when the rover can connect to the Mars Renaissance orbiter, we get more favorable speeds of 2 megabytes per second. However, this link is only available for about 8 minutes each sol or Martian day. As you would expect, sending HD video at these speeds would take a long time. As nothing really moves on Mars, it makes more sense to take and send back the images. In order to create a video like this, several images must first be stitched together to create a mosaic or panorama. Depending on how many images are connected, you may sometimes see black areas where no image was taken. We have done our best to preserve the 4K quality by not zooming in, while also trying not to include those areas, but you may see them from time to time. By taking these mosaics and panning across them at 60 frames per second, we have created the most lifelike experience of being on Mars. This image is the largest mosaic ever put together and was made from over 1,000 images taken by Curiosity between November 24th and December 1st, 2019. It contains 1.8 billion pixels. As we zoom in, the quality does not diminish. At this zoom level, what you are seeing is exactly 4K quality. The rover was exploring the area named Glen Torridon, which was theorized to contain large amounts of clay. Clay found on Mars signals the presence of water in the past. At this point in 2020, the NASA rovers have found irrefutable evidence that Mars was once a watery planet. You may be wondering why the sky color varies from image to image. The true color of Mars is reddish and hazy. In some images, however, the sky will appear blue and bright like on Earth. This is due to the recoloring of images done by NASA in order to aid geologists identifying rock formations. This technique also produces a much clearer picture, so we can see Mars in much greater detail. Curiosity is the only rover still active on Mars. The previous two rovers, Spirit and Opportunity, unfortunately succumbed to the Martian environment. They were launched around the same time, landing on opposite sides of the planet. Twin rovers, they are considered one of NASA's most successful missions. Spirit became trapped in a sand dune and lost the ability to charge its solar panels after 6 years of service. Opportunity outlived Spirit, roaming Mars for 14 years and making astounding discoveries. Opportunity was lost in 2019 after experiencing a massive dust storm and essentially freezing to death. NASA's newest rover, Perseverance, is scheduled to land in 2021. It will deploy a small helicopter called Ingenuity. Ingenuity will scout the path ahead, warning the team at NASA about any sand traps awaiting the rover. Flying on Mars is no easy feat. With an atmosphere much thinner than Earth's, its blades will reach up to 2,400 revolutions per minute. That's 40 spins every second. Most helicopters on Earth operate at just 500 revolutions per minute, which is just over 8 spins per second. This video was an exhibit of the high-quality images available of the Martian surface.
For more updates, please share, like, and subscribe for V News and Trending.